Hey and welcome back. Today we're breaking down copper cabling, the very physical wires that carry your data from point A to point B. Simply put, copper cables are the backbone of most wired networks. They transmit data through electrical signals over metal wires, connecting things like PCs, routers, and switches. Think of copper cables like roads for electricity. Small highways that let millions of tiny cars, electrons, carry messages between devices. The smoother and more protected the road, the faster and cleaner the data can travel. Copper cables have several different variations, each with its own design and purpose. But it really comes down to coax cables and twisted pair Ethernet cables, with Ethernet cables having the majority of the variations. Coaxial cables use a single copper conductor in the center, surrounded by insulation, a metallic shield, and an outer jacket. Most of it today is used for cable internet, satellite TV, and some CCTV systems. Its shielding makes it great for reducing interference over long runs. However, it's bulky, harder to work with, and slower than Ethernet for modern networks. Twisted pair Ethernet cables, on the other hand, are now the standard for modern networks. It uses pairs of copper wires that are twisted together in order to reduce electromagnetic interference. The main types are Cat5e, Cat6, Cat6a, and Cat7, with Cat5e up to 1 GB a second at 100 meters, Cat6 up to 10 GB a second at 55 meters, Cat6a with 10 GB a second at 100 meters, Cat7 with 10 plus gigabytes a second with extra shielding and even less interference. Each higher category comes with improved bandwidth, speed, and noise resistance. However, it also comes with more cost and can be harder to install. That being said, there is something to be talked about when it comes to the difference between a Cat6a and a Cat7 and why one is certified by the IEEE and not, and things like that. And we're going to discuss that in a later video. But let's talk about shielded and unshielded. There are also different types of shielded twisted pairs, but we'll get into that in a different video. UTP stands for unshielded twisted pair. This is the most common. It's flexible, cheap, and sufficient for most home and office networks. STP stands for shielded twisted pair. This adds a foil or a braid around the pairs, protecting against interference. Ideal for industrial environments or areas with lots of electromagnetic noise. There are overall pros and cons of using copper cables, just like there is with everything else. Some of the pros are that it's affordable, easy to install and terminate, backwards compatible across generations, and it works well for shorter distances, under 100 meters. The cons: limited bandwidth compared to fiber, prone to interference over long runs, signal degrades with distance and noise. It is important to note that all of the Ethernet twisted pair cables except for Cat7 use an RJ45 connector for termination. They also follow the TIA EIA 568B standard for consistent pinouts. That's where our pins are in different orders, and we'll talk more about that later. Also, you want to avoid any type of tight bends and running parallel to electrical wires to avoid any type of crosstalk. Okay, so to recap, we have two different types of copper cables. We have coax, which is kind of getting phased out and is not really used for network anymore. And then we have the twisted pair Ethernet cable, which comes in multiple different categories and can be shielded and unshielded. And that's all I got for the video. If you liked it, make sure to smash that like button, subscribe so that way you don't miss further content. And remember, work with what you got, build what you need. And I'll catch you in the next one.